This is the ROS Developers Podcast, episode 77.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today we are going to interview James Bruton. Today, James Bruton is an electrical and mechanical engineer who dedicates to build robot projects and post the whole process online on his YouTube channel. He has been amazing robots and other stuff. For example, he has built a live version of the BB-8 robot from Star Wars, and he has also built the Batman skateboard, and also has built a version of the Open Dog robot, that is available online. So what can I say about him? He is the real robot maker that is dealing and doing processing. What can I say is about documenting his process on YouTube. And today I'm going to interview him, but unfortunately there was a problem in the video recording. So that's why I'm recording now this extra introduction, because we missed all the full introduction to James and some other stuff, just a few minutes, but it's not a clear video. So what I have done is to record this extra introduction right now so I can publish the video. Even if the quality is not very good, we have some issues there, but I think that is interesting that you see James Bruton on his own lab, robotics lab, and you're going to see many of his amazing robots there on the background, and he's going to talk about that. So that's why I consider important to publish the video even with this low quality on my side. All the reasons related to the problem are on my side. It was completely my fault. I'm sorry. And what can I say? We'll try to do it better on the next time. Okay, so then let's go to the part of the interview, and I hope that you enjoy this video. Okay, understood. And then, so can you tell us what is the purpose of your YouTube channel?
So mostly the purpose is to show people how to do things. So that's one of the reasons I started my blog before YouTube in 2004, because I really wanted to build bipedal robots, and I couldn't find anything online at the time that told you how to do it. So I thought I'd find out and I'd publish it. And obviously it's quite tricky, which is why there's not that many guides on how to do it. And I worked all my way up to sort of 10 versions up to Robot X, which just about hobbled along. And then of course Robot Dogs came along with Boston Dynamics, and I thought that'd be a good thing to do as well. And now we're on to sort of the 5th version or something like that, despite being called Open Dog version 2. But everything I publish is open source as well, so that stuff is on GitHub. So yeah, as much as I can, it's instructional as well as doing it so you don't have to if you don't want to, and you can still understand all of it.
Exactly, and they can also take this as a base for further projects, so they don't
Yeah,
start on
absolutely.
you. Did you have any person that reported to you they have been using as a base any of your project and they have developed something on top of that?
Yeah, so I know there are people who are wanting to build OpenDog. There's a university in the north of England who are doing my version 1 OpenDog, which I never really made walk properly, but they're taking that on to try and make it work. There's at least one person making OpenDog version 2, which is this one here, and various other, the mini dog that's somewhere over here. I know at least a couple of people building that. Someone definitely built my Sonic the Hedgehog 2-wheel balancing robot, because I've seen video of it. So yeah, often people do, they either just try and build it exactly as it is, which I don't necessarily always recommend, or they use it as inspiration, or they just take the code and use that. There are some things in Sonic the Hedgehog for using CAN bus with the Teensy, so that's quite useful code with different nodes for sensors or whatever. So you could take whatever you want away from it, really.
Okay, amazing. Very cool. And then can you explain to the audience which kind of project do you build? You already have said some of them, and
Hmm.
also some time. So you mentioned that you started by building. What's the word that you used? It
Bipedal
was
robots, so two-legged walking robots.
no. When you started at the beginning, there was something about movies
Oh,
and
okay. So, so I started building robots first, and then I decided that I should
okay,
do movie props. So at some point I built an R2D2. That was
prop.
before YouTube as well. And then the movie
Okay,
Iron Man came out in 2008. So then obviously everyone wanted an Iron Man suit. So that became a 4-year project. And in fact, my top view video on YouTube now is 4 minutes, 4 years compressed into 4 minutes for that project. So some of the
wow,
early clips in that, this had 65 million views or something. So some of the early clips in that are the first serious videos I made for YouTube. Back in like 4x3 grainy old DV cam, so a bit of a legacy. But yeah, that's really where YouTube started to get popular, and I got lots of subscribers, and then I kind of carried on doing robots and doing movie props like BB-8.
okay, and then. So let me see the questions that I have here. So from all of them, so which one has been your most successful project, and or let's say the one that you are more proud at, and why?
It's difficult to say how you rank success, isn't it? So I guess if it's YouTube views, then it's building an Iron Man suit by a long distance. And that video still does 500,000 views a month or something now. Even though
Wow.
it's 4 years old and it was made of videos from the previous 4 years. I suppose the most successful in terms of robotics, probably we're looking at OpenDog version 2, because that's the one that walks properly. I've only really just started to make it walk, but it looks like it's going to be much better than anything else due to its inherent mechanical design. So it's quasi-direct drive, so back-drivable brushless motors that act a bit like a spring with a holding power. So that's what makes it work, basically. I'm working on another video for that now. I'm
Okay.
not sure what else really. Yeah, there's just been
Okay.
so many
So the
projects.
one
There's a
that you
video
are
every
more
week, so
proud.
yeah, it's probably this one. That's the one that will go to shows, I expect, when the events start up again.
Uh-huh. Okay. Yeah, that's amazing. And you mentioned that the uh, first version of the OpenDoc it
Yeah.
didn't work properly. What can you explain us? What was the problem? Was the problem in the algorithms, or was also embedded into the mechanical structure that didn't allow it?
Yeah, mostly mechanical. So it's this one that's on my T-shirt. Actually, it's lurking down the back here
Uh-huh.
somewhere. You can just about see it. This so basically, it's all driven by ball screws and brushless motors. So it's very, very rigid. It's also very,
Uh-huh.
very heavy because those 1605 ball screws weigh quite a bit. There's 12 of them, and there's 12 big brushless motors, and all the frame is aluminium and stuff. So it's a two-man lift, and it's not very agile. It's got lots of power, mind, but trying to make something that complies with the ground and everything is very hard to do, because it would have to have sensors, and then you'd have to drive a loop round of sensor data and processing, and then deciding what to do with the legs. So I mean, it kind of
Yeah.
walks along. It can lean right over and take one foot off, and then lean all the way back, and then walk very
Uh-huh.
slowly. But it's very wobbly as it goes, and it's massively heavy. Whereas OpenDog 2 is a low as 5-to-1 reduction on the biggest brushless motors I could put in there. So you get that
Uh-huh.
natural spring in the legs. It's much more agile. It weighs about 20 kilograms instead of 50. And
Wow.
it's just much faster as well because of the low reduction. So it practically keeps itself stable by just hitting its springy legs on the ground at the moment. So yeah,
Okay.
no
And
no dynamic stability at the moment, just purely the dynamics of the motor holding power.
okay. Okay. And what about the algorithms that you are going to, or you have already implemented in the OpenDoc version 2? So do they have any special, are you applying any special technique of, let's say, central pattern generators or any other special algorithm for controlling the walking and synchronizing the gait, providing a proper gait?
Well, that's the thing. So not really. The walk that it does at the moment, which was in part 6 of the video, is just fixed timers and fixed positions for its legs.
Uh-huh.
So
Okay.
it's basically picking up diagonal legs, 200 milliseconds up and down.
Uh-huh.
And as I push around on the stick, then it's moving the legs on the ground one way and the legs off the ground the other way to take steps in each
Uh-huh.
direction. So sidestepping front and back, and also in yaw to rotate. And that's it. and all of the other
Okay.
stability is down to just the springiness from the motor holding power. So there's no springs in it,
Okay.
but it's just the O-Drive Robotics drivers that are with their PI controller just trying to hold the position, which are tuned to make it springy, and so the whole thing is just inherently stable because of that.
Okay.
So there's
Okay.
nothing
Okay.
else at the moment, and that's why it's quite good to build different versions of hardware, because the first one is different mechanically, but the software is no different, but it doesn't walk. And this one does because it's got that inherent mechanical system to make sort of evens everything out. It's like jumping on a pogo stick or 4 pogo sticks. You tend to stay upright.
Okay, okay. Yeah, I see that. So that's a mechanism that, or technique for making it work. That
Hmm.
so you have recorded the prepositions and so on. That's exactly the same that Aibo robot. You know this RoboDog from Sony. Do you
Oh
know the
yes, yeah,
Aibo
yeah,
robot?
yeah, yeah.
So that's how it works. It
Sure.
works and how it works. So they work by they are pre-recorded positions and they are reproducing that in order to
Yeah,
produce
sure.
the game.
Hmm.
Okay, great. And what also? Let me see here my question. Uh, so about the projects. Okay, so you have many different projects there. So
Hmm.
how do you decide which one is going to be the next project? Do you have any interaction with your follower audience? Are you accepting suggestions, or it's just that you think that this is going to be cool, and then because of your own interest, personal interest?
It's mostly personal interest. I don't get too many suggestions that are practical. I kind of have this concept of ongoing projects like OpenDog, which will go on and will have better algorithms and will eventually run ROS and will do navigation and so on
Wow, that would
once we
be
get there. So that's
awesome.
at the moment it's only the very rudimentary walk that I have. So that's got a lot more mileage in it. And then I
Uh,
have something, every other week usually there's another project. So the most recent was this shoulder, the ROS robot that I brought out second part of
yeah.
this week, which is really to get into ROS, to learn ROS before I try and put it in other robots.
Uh-huh.
And then sitting right here is the HAL 9000 that balanced on a ball, which was revisiting my first BB-8 you mentioned. And I still need to build another
Mm.
version of a ball balancing robot based on that one. So it depends. I've got a Trello board, and I've got all of my ideas, and I try and bring them forward and see what's coming up, and try and schedule them and get the parts ready and so on. So yeah, it's pretty
And
much just doing what I want.
okay, that's very cool. You're very
Yeah.
lucky, and I can see that the audience is thinking, "Well, how lucky is this guy?" Because we are mostly roboticists, and
Hmm.
then we also would like to dedicate the whole day to do those things. So
Yeah.
so super cool stuff. And then so have you planned already the rest of the year with projects, or are you deciding as they come,
Yeah. So
as
I'm
long as you
planned.
have?
I'm probably planned about 3 or 4 videos in advance,
Uh-huh.
so I know what's happening up to the end of September very roughly at the moment.
Okay.
And as I can
Okay.
start
So
those things and they work out or they don't work, then I start, put some more things on the other ends and start doing R&D and research and so on. So, yeah, one of the things in October is going to be another ROS robot, a bigger one with a robot arm on.
okay.
So, yeah, so the robot here is sort of mostly copied from the Nox robot project I found on GitHub,
Mhm.
and along with the stuff I learned from one of your courses. So, yeah, it kind of works, but it's a bit sketchy. So, but we're going right back to the hardware really, because the motor encoders aren't even attached properly to the wheels. So there's a lot of things to be rebuilt in it. So I'll be building something bigger with brushless motors in, a bit bigger with an arm on of some sort that can manipulate things. So that's probably October sometime, but that's as far as I've planned it.
Okay. Okay. So cool. Then maybe you can use move it on that arm and then make it also grasp things. And so, are you planning to put it also vision as a
In what, sorry?
sensor, a camera for doing artificial
Yeah,
vision, something?
Yeah, so I'm going to be using some NVIDIA stuff, some of the deep learning models on the Jetson
Ah,
range. So NVIDIA are
yeah.
giving me a hand, but it's quite easy actually to spin up a vision recognition thing in a few lines of Python that can recognize household objects.
Yeah.
So yeah, I'd like to get to a position where I can tell the robot go over there and get that cup off the table, And
Yeah,
it uses
exactly.
ROS to navigate because it knows where the table is or thereabouts, and then it
Uh-huh.
can look at the table and see what it thinks is a cup, and then manipulate the cup, and then bring it to wherever you say
Exactly.
next, effectively. Yeah.
Exactly. With the YOLO darknet system that already also exists for ROS, so you can
Okay.
have the whole pipe integrated into your robot using only ROS. And then also for grasping, there is
hmm
some packages that are called Movit,
Okay.
which is the one that's going to provide you with the kinematics and all that for your robot.
Okay.
Okay.
Sounds good. I
Yeah.
haven't
So
decided which way to
just
do
for
it
the
yet, but yeah.
okay. So you can explore, but just want to clarify to the audience that you mentioned that he is learning by using our academy, one of the
Yeah.
resources, of course. Okay, so many others, and we are so proud. So for us, it's an honor that you are learning using our academy. Very good.
Right. Yeah, I found it quite
And
good. I'm still very much learning though, so yeah, I've just about made a robot that navigates, but it doesn't work very
uh-huh.
well. So there's a lot of the cost map stuff and all of the configuration I still need to delve into in the next version. So
Okay, yeah, configuring the cost maps and all the parameters that are in the navigation system is a little bit tricky, let's say,
yes.
because it's so many, and it's, if your robot is a little bit different from the standard uh,
hmm
wheel, circular 2 wheels differential drive and so on, then you have to start tuning there and doing a lot of. We can talk later, maybe,
Okay.
if you
Sure.
want it. I can give you some hints there. Okay, so Jen, so can you tell us a little bit more about the process that you follow in order to, since you get the idea, okay, so that would be cool to do this, then you have your video on YouTube published. Can you give us a rough idea of how is your process?
Yeah. So I tend not to try and do too many new things at once. So I'll have kind of what building blocks I'm comfortable with. So driving brushless motors with O drives, if I need to do that in a project, I know how to do that. Using ball screws and things, they were used in several projects, and they actually, if you were to look at the CAD, you'll find it's exactly the same motor, exactly the same spacing, same pulleys, exactly the same belt. So it's practically a copy and paste of that module from one project put into another. So that's like another
Uh-huh.
module because it's a really good, low backlash reduction. So let's use that. Obviously, radio control servos and anything else. So and 3D printing. I've got a CNC machine, but I wouldn't, it was OpenDog was really the first project I used that, and I did it bit by bit, and now I've used it in other projects. So really, if I'm thinking of a project, I'll think about, do I already know how to build it? Or is there something else I can put in that makes it more interesting I need to learn? And, but I won't learn 10 different things to put into a project at once because I'm kind of reliant on making that content. I do
Uh-huh.
YouTube full time and I need to get the content out to earn money basically. So yeah, so doing ROS, I did a video about ROS and about NVIDIA's deep learning models, and I bought a turtle bot, and I did that first, and then obviously went through the instructions from Robotics to make it work and demoed it, and then I started working on that robot to see if I could achieve a robot that navigates, and that's still not perfect, but it kind of works. So I've got my head around how ROS hangs together in that respect. And so the next one will then be the one that's got brushless motors and it's bigger, and then it's probably, hopefully, navigates properly, and then it'll do something else that have an arm on it, etc., etc. So, and in the meantime, there'll be lots of other projects that come along. So I'm not doing it back to back every week, and I'm not. If I get stuck, it's fine. I can put some other video out.
Uh-huh. Okay. I see. Wow, that's a lot of work. And also, I see the progressive method that you are
Absolutely.
following. So, okay, that makes perfect sense. Right.
Yeah. So the
Right.
robot
Otherwise,
dogs. Yeah. So the
yeah.
robot dogs, when I did OpenDog 1 and it was massively heavy, I'd already worked out how to do inverse kinematics for that. That was really the learning for that one.
Uh-huh.
And then I did the mini dogs. There's one there and there's one on the floor. You can just see in the corner. So I did
Uh-huh.
those, which were radio control servo dogs, to see if I could actually make a dog that walks. And when that worked, then I went on to OpenDog 2, but I'd already done 2 other test dogs for quasi direct drive that I did last year. So then what's that? Six different dogs. Every time doing a little bit more, checking I know what I'm doing as I go.
Yeah. Okay. Okay. Yeah. Sounds amazing. And the I have seen the videos for all those robots that you
Mm,
mentioned, and yeah, eager to see the one of the robot dog walking.
yeah.
That's yeah. That's eager to see that one. And
Okay.
then how do you finance yourself? So I'm pretty sure that many listeners would like to know about that because they are probably inviting you in the good sense. Okay, so they are inviting you. That they would like to do the same thing.
Sure. Well, as I mentioned, it's a rather long story to going full time on YouTube. That's been many years building up a following. The main place that money comes from at the moment is from brands. So when you see those 60-second ad segments for Audible or someone like that in there, I think the ROS2 video is for Busu, the language learning app. So that pays some money for putting those ads in the videos. Obviously, there's advertising from YouTube, but that isn't very much. And the other one is Patreon and YouTube channel membership, which is sort of stable income really for people who want to fund me. Ultimately, they get the videos early and a couple of other benefits, but ultimately they support open source and they want to see my projects built. So and they might put $1 in a video or $1 per month, and all of that adds up, and that's quite helpful. So that's been one of the main things that allowed me to do YouTube full time in the first place.
Uh-huh.
But yeah, branded builds is the other one. So I've got a big robot project coming up. Starts next Tuesday. It's actually for Lego. It's a two-part
Uh-huh.
series. So there we go. Can't tell you
Okay.
much else at the moment.
Okay. Okay. Well, but we got some news, some exciting news here
Yeah.
in the podcast.
So
So
that's
that's a project that you get paid for.
yeah. So for the basically for the build to promote the Lego product that they want to promote, it's a Lego that robot that shows you Lego. That's all I'll say at
Uh-huh.
the
Yeah.
moment.
Yeah.
That comes out. It's next Tuesday, the 25th. Not sure when this is going out. It's the first video.
Okay. Yeah. Yeah. So on the next Tuesday, so it's going to be out on the Monday, next Monday.
Tuesday.
So
Is it the 25th, 26th? Next
20,
Tuesday.
yeah, yeah. Next Tuesday is, let me check it here. Next Tuesday is
Pretty sure
the
it's the 25th.
25th. 25th. So the podcast is going to be published one day
Oh, sorry.
before.
Right, got you.
So is
Yeah.
that okay with
Yeah.
you?
Yeah.
Yeah,
Absolutely.
okay. Okay, so
Yeah. So then.
listeners that are listening to the podcast,
Yeah,
then
that's it.
have a look at the at James' channel. That you have a link on the show notes of the podcast. Then have a look at this on in tomorrow.
Yeah,
So
that's it.
tomorrow Tuesday, because it's going to be a new. So what's the name in English when you are publishing something? The premiere, can we
Oh, I
say, or
suppose so. Yeah, Premiere.
the
You
premiere?
say that though, although patrons and YouTube channel members have it already because they get the videos early. So
Ah,
if you're a patron, you've
okay.
already seen it probably.
Okay, so yeah, exactly. So also you can consider to become a Patreon of James, and then you will have the luxury of getting the video before, so you don't have to wait until tomorrow.
Yeah,
Okay, great,
but you
great,
probably
and
you'll probably get the next part in the series tomorrow as well, even though it doesn't go
okay,
public the week after. Which is
uh-huh.
quite good. Yeah,
Okay, 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 okay. So lots of benefits,
yeah,
guys, and also we have to support James for all the good projects that he's delivering to us. Actually, because they are for free, so they are published. So that's a question. So you are publishing everything from your projects as open source in a
pretty
Git,
much.
or
No, just open,
uh-huh,
just all the CAD and code is uploaded to GitHub. Yeah.
uh-huh, okay. And which program are you using for designing the mechanical parts of your
So
projects?
I'm using Fusion 360, but I export a step on STP from that, so it's a solid model which I actually
Mm,
publish. So you can modify that. Obviously, if it's an STL, it's really hard to modify because it's a mesh. Whereas I
mm.
publish a solid model that you can import into any CAD, and it's like you've drawn it, so you can pull and push all the faces and do what you want to it. So
Okay.
the actual
Uh,
source, effectively.
okay. Okay. So I was asking you about that because if you want to use your robot in ROS,
Hmm.
it's very good to have the URDF model of the robot.
Yes.
And then there is a plugin in SolidWorks that
Okay.
allows you to transfer your design, your CAD design of your into and generate automatically the URDF model, so you
Oh,
can
okay.
actually start using it. So I don't know about that other program that you mentioned. It's
Fusion, yeah,
called
there might be. There are
Fusion.
plugins. Fusion, it's Autodesk Fusion 360, but it's free to
Okay.
enthusiasts. So it's quite good for the community. Whereas SolidWorks costs quite a bit, doesn't it? So
Yeah, yes, it's very expensive. And there is another one that is very cool. Which is web-based, so you don't have to install anything, and it's
oh yeah,
called. And they have an open source layer. Now I don't remember that we use a lot here at our
okay.
company.
Yeah,
I don't
is it the
remember the
one that looks
name.
like SolidWorks? I can't remember what that's called. I did look at it once.
Yeah, that one.
Yeah,
That one exactly. Yes.
I can't remember either.
Okay.
But yeah, okay.
Yeah. Yeah. Okay, so I will check it out and put it on the show notes also.
hmm
Okay, then let me see. So we can say that your project, so they are more mechanics and electronics based rather than software based. So can we say that? So
I
I
guess
mean
so.
that you do.
Although, if you think about BB-8, for instance, there's still code running on a
Uh-huh.
microcontroller that's reading an inertial measurement unit to see how it tips, and that's dynamically compensating to hold it stable all the time. So without software, it wouldn't work at all, really.
Yeah.
It'd be really wobbly. So it depends how you look at it. But
Yeah,
yeah,
yeah.
they're
So
mostly on microcontrollers, I think, is what you're getting at.
exactly. It's like the control code. It's like the basic control code. Let's say, for example, if there is a drone, so the code that makes your drone be stabilized,
Yeah.
well, but not the one that does a mission.
Yeah,
So
sure.
goes into the forest and then detects the person, then goes and follows the person until so that something that you can start doing by entering into the ROS world, right?
That's it. Yeah.
Because yeah,
That's one of my main
okay,
motivations is to make more intelligent robots, essentially, that can do more things like navigate and so on.
exactly. That was one of the questions I wanted to ask you is about
hmm
why, because you have been doing so many projects, and all of them, if I'm not mistaken, none of them, sorry, none of them, they are using ROS. So just started with the Targerbot 3 video that you
That's it.
published.
Yeah.
I also saw that one. And then now this series about your navigation robot. So that the reason was to that you mentioned is to make more
Yeah.
intelligent robots.
Yep. So basically, yeah, take all my projects to the next level, essentially, and yeah, have them do intelligent things with machine vision and various other things. And so I guess the main thing, the main reason for doing this, I really like, even with Arduino, I like using libraries and other people's code. I pretty much live on Arduino libraries. And I guess ROS is a similar thing to that because there's so many code modules already exist, like all of the
Yeah.
mapping and navigation. Writing that all yourself from scratch is going to be very difficult to do. So,
Yes, exactly. And there are two versions of ROS. ROS
hmm
one, let's
yeah,
say two versions. Yeah, ROS one and then ROS two. So um, any reason why you started with ROS one?
mainly because, well, I learnt it in your course, and also there's lots of
Okay.
examples out there, and there's far more documentation as far as I can tell. And I barely understand that, so it didn't seem a good idea to jump into ROS 2. And I've really no idea what the differences are, to be honest. So,
Okay, no problem, no problem. So yeah, so ROS 2 is more mature, let's say, but still lacks some functionalities, and
mm,
it's a little bit more difficult. It's like in the early years of ROS so 1, so at present. So if you can achieve most of the things that you are doing with ROS 1, but it requires a lot more of work to be done by you. At present,
okay,
you have so much stuff done with ROS 1 already that you can just grab and 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 use it. And then the question is how did you get introduced into RAW? So because I imagine so you are doing your projects with your amazing mechanical and electronical designs, and then at some point in time then you decide to do ROS. So how did you get into notice that ROS existed that could be applied to your robot?
I think I've been aware of ROS for a very long time, but I just haven't really looked, or at least I have looked at it, and then I didn't understand it. So
Okay.
yeah, I just thought I would just get on with it and do it, and that's why it's you know, a two-part video series to build this robot and another one about Turtlebot, because otherwise I don't have time to do the content, so it has to become content.
Yes.
And I might as well vlog along and tell everyone about my experience and try and explain it as I go. And I'm sure by a few more videos, it'll make more sense and hopefully work better. But yeah, so sort of yeah, just learning as I go, really.
Okay. So yeah. So you were aware of its existence, but never found the reason to use it as or overcomplicate your project, right? Until now that you decide to go more into
Yeah,
intelligent
I think
robots.
it's time to do something better. Yeah, do better. You know, more intelligent machines.
Uh-huh. Okay, great. I love it because for me, so I work with robots, but my main interest is the intelligent part of the
Yeah.
robots. So that and that's very cool, very cool. Eager to see your next videos about applying ROS to your robots. That's going to be awesome. Let me see here my list of questions. So oh yeah. Well, before another question here, let me ask you another one that popped into my mind. So, what about the response from your audience about switching into, not switching, but introducing ROS into your projects?
Yeah. So the first one I did, the first video about Turtlebot, the views were higher than normal on that. But the last two, well, the last one's done terribly actually, which was it's 36 minutes long though, trying to get all the navigation stuff to work. I didn't expect that to be a super viral video because you really gotta want to know about ROS to watch all of it. Um, but it's got to be, I've got to put it down on video really, so it's complete. And hopefully the ones in the future I can refer back to it, and I can make something work a lot quicker. You know, more with highlights and then just publish the code. So they'll probably hopefully be more popular. Um, but yeah, so I think once things work and I've got more intelligent machines and I can put that into every project and I can put it into OpenDog, and then that's part of that OpenDog series as well to make it walk around by itself, then that's really where the interest will come from subscribers. And you know, putting vision recognition into other projects, perhaps automated nerf turrets or something like that, or some other intelligent real Terminator, you know, spin on it.
Yeah,
So
yeah,
that's really
amazing.
where the views will come from and the interest, I think, rather than this is how you write code for ROS. Coding videos never really do very well.
Okay, I see. Yeah, that's what happened to us. That so
Mm.
we have many coding videos because our academy then we teach how to create code for robots, and it's true. So they are not getting so many views. But I can tell you that I share your videos about your ROS robot, and they were quite a success based on our standards. Okay, not your
Okay,
standards.
right.
Okay, because let me tell you, tell the audience that James has almost 1 million followers in his YouTube channel. Okay, so those are big words. So in the ROS community, it was shared among even among this open source robotics foundation. You know, they
Oh
are
yeah,
the
yeah. So they followed me on
creators.
Twitter. Yeah, mm.
Yeah,
Yeah.
exactly. So I saw that they started to follow you, and even Luis Jimeno, that is the he is developing some libraries for quadrupeds,
Oh yes.
and
Is that Champ? The Champ
yes,
thing?
exactly that.
Yeah, yeah. I saw that.
The
Yeah.
Sam.
Someone actually got my CAD for OpenDog 2, and they
Yes,
made a Champ simulation and did a URDF file, and all that's already done. So
that's it. That's
that's
Luis
quite good to
Jimeno.
see. Yeah. Right.
Is one of the developers of the
Right.
Cham library.
Okay.
Yes.
Cool.
So what? So I'm sharing this with you just to let you know that you are having success in the ROS community.
All
Great.
right. Good.
Let me see my question. Um, so I see that you have built a lot of projects of robots, but then you move into the next one. So what happens, does it happens to the previous ones that you have done? So do they still work, are working, or maybe you take some pieces from some of them and then use it into the new projects, like in the typical labs of the roboticists, that there are parts everywhere, but when you are moving to the next one, the old ones doesn't matter anymore.
Yeah, a combination of that. Some things are stored in a warehouse, and some things I break down. So it depends. So largely, it depends if they worked quite well, and if I think that I can take them to an event and demo them, I'll probably keep them. So Sonic the Hedgehog, the two-wheel balancing robot, that's still in one piece, although I took the O drives out for something else. The ball balancing robot I did last is just here. The ball is up the other end, but I'll be tearing all its electronics out to put in the next version because that one didn't work very well. OpenDog 1 is still here, complete, apart from the O drives I took for OpenDog 2, and I don't know what to do with it, but yeah, we'll see. The next time I need some brushless motors, I'll probably take some motors off it. We'll see how it goes.
Okay.
Yeah, so a combination really of tearing things down. Not everything can be kept, and some things
Yeah,
get
I
stored.
understand. I'm asking you that question because so it happened to us that, so you present something and then people get with that something in their minds, and then sometime 2 years later they come to visit you and they are expecting to see all that, and they request you to do a demo of this, and you can not
Yeah,
do that, and they don't understand, it's because for
that's
them
it.
it's
Yeah.
like switching off the TV, then you switch it on again 2 years later, but that's not how it works.
Yes, that's absolutely it. Yeah.
Okay.
But hopefully I've got things working that are good, and I can show them the current stuff instead.
Exactly. That's the point. Exactly. The latest one, that is the
Yeah.
coolest one, right?
Yeah.
Okay. Okay. And then, so let me see, because all the ROS questions, they have been already answered here. Related to the ROS question, so you have started to apply ROS into your robots, and then which one has been the most complicated thing for you to learn about ROS?
That's a difficult one. It's all I guess I kind of took it in chunks. So just understanding that command velocity drives the wheels. I guess TF was. I didn't get my head
Yeah.
around TF properly for ages until I read a lot of forum posts. And I'd already looked at the ODOM Arduino, the ROS serial Arduino library example. It's called ODOM, but it doesn't publish an odometry messages. It publishes TF, and it publishes a static ODOM and then a moving base link that drives in a circle. And it's a piece of Arduino code. And I looked at it when I was trying to work out what it was all about, and I didn't understand it at all. And then I went and looked at some forums, and I bought the Turtle bot, and I had a look at that, and I looked at all the messages and all the topics. And then I went back to that example, and then I totally understood it. So I guess, you've got your ODOM that's stationary, then you've got your robot base link in the environment, and everything else referenced from the base link, that's the laser, and then everything else, right? And then I totally understood
Correct.
what it was I was looking at the first time.
Yeah.
And looking at the TF page on the ROS wiki just
Wiki.
didn't mean anything the first time at all. So I guess having done the course and having actually got a robot, the Turtlebot's been really helpful actually, and read the book from Robotics as well that they published all about ROS.
Yeah.
And looking at those diagrams of the laser and the how the transform is showing where the laser is with reference to the base link, and it's like 20 centimeters higher, and then all of that stuff. And then going and doing it as well as kind of is the best way to learn, I think, is actually by doing it.
Yes, exactly. Yeah, now that you mentioned, it's true. The TF is one of the concepts that we struggle the most. Also for me, when I was learning about ROS, and but it's so good invention.
Yeah.
It's so useful. It was horrible before we had TF, when you
Oh,
have
okay.
all those different, because before ROS, so you
Oh,
didn't
okay.
have
Yeah.
TF, so you had to compute everything related to the different positions by yourself,
Yeah.
and doing all the math. Wow. And then you have many errors until you get it right, but then it only applies to that specific robot. And so it was so thanks that we have TF. Thank you.
Yeah, I think the most satisfying thing was driving the robot on the floor and seeing it moving in RVs and it being in the same position and them both being in sync.
Uh-huh. Which one? Sorry.
So driving the robot and having it publish
Yeah.
TF and seeing it in
Yeah.
RVs and having the physical robot and then having it move in RVs as you drive around
Ah,
and
okay,
seeing
okay.
it do the same thing, and then it felt like I understood ROS suddenly, that was working.
Exactly.
And then it's like, right, now
Exactly.
ROS is saying my robot's here, and it is.
Yes. Okay, okay. Yes, exactly. Good. Very good. Okay, so we have almost finished the interview. So
Okay.
let me ask you for your plans for the future. So you mentioned about this project that you are doing about Lego, and also that you are thinking about more ROS projects using NVIDIA. Can you tell us more about this?
Yeah, so pretty much what I've said. So the first step will be building another wheeled robot, something slightly bigger. I wanted to build something like the Willow Garage PR2 robot, with the arms and everything. But
Uh-huh.
it'll probably just have one arm, and I know there's a few other robots like that. But it'll be a bit, a
Mm.
4 foot tall, kind of useful robot that can reach the table. And I think that's going to be the
Mhm.
first step, really, to getting the navigation stack working properly on that robot, and then having an arm, and then having the vision integrated into it. I've got a few other ideas for deep learning stuff, the NVIDIA stuff. So there's one example with single webcam for skeleton pose estimation, where it draws a green line over you like a Kinect sensor would, but it's done with a
Mhm.
camera using deep learning. So I've got several applications for that as well, for gesture-driven projects. Whether they'll actually have ROS on or not, I don't know, but why not publish the data over ROS and have it network aware? It's ultimately fundamentally a communication protocol, so that's useful for many things. And then probably, putting ROS into other projects, so into robot dogs and so on.
Yeah, the robot dog, you have to put it
Yeah.
into that. That's going to be awesome to
I think
have
to
the
start with,
robot
though, I
there.
probably won't be actually driving the joints with ROS. I'll be driving them with the microcontroller that controls the gate, and then trying to
Uh-huh.
estimate try and get it to publish TF and an odometry message based on how big the footsteps are. Maybe a magnetometer, because I think it's going to be a bit hit and miss, and try and fuse that data together and then try and do it that way and see how well it works. It's a bit wobbly when it walks at the moment, though, so I think the laser will just get shaken all over the place. So
Uh-huh.
trying to modify that gate to make its body move more slowly and more smoothly will be one of the things. But I've also considered putting the laser on a gimbal that can stay
Uh-huh.
stable as it moves. So we'll see how it goes. But it'll all be on video anyway as a exploration into ROS and into those robots.
Yes, and also it could be kind of a standard platform for doing quadruped and research or practice, because the quadrupeds, I don't know why I'm feeling like a lot of people is pushing quadrupeds right now,
Yep.
but all of them, they are very expensive. So what about this, the one, the open dog? Can you tell us more or less an amount of money that it will
Yeah.
require to build one of those?
So it's got 12 motors in, and those motors were £140 in money each. And then it's got
Wow.
6 O drives, and those are about £150 each. And then the rest is 3D printed and normal belts and stuff. So I think it's about £2,000, something like that, to build. But it's cheaper than $74,500 for Spot Mini.
Exactly.
But obviously,
Exactly.
it's never going to be as good as Boston Dynamics.
Yeah.
But
Well,
then it's open hardware, so anyone could write better software.
exactly.
But I think probably we need better than 5-to-1 reduction ratio. It's all belt drive at the moment, which is why it's only one stage. So yeah, I've considered modifying it or doing another one that's nearer 8-to-1 with bigger motors still, which might just about be okay. But there's some limits there with what you can do with 3D printing. So planetary gearboxes I'd considered, but I think with plastic gears it'd probably just strip with the velocity it needs to move at. Whereas belts are quite forgiving, and because the belt goes around multiple teeth, you can have a 3D printed pulley with no problem. So weighing up the pros and cons there, but it's potentially an effective platform.
Uh-huh. Yeah, and about, you mentioned about putting a laser on top of the robot. So
Yep.
by doing that, then you can do directly the navigation. So you can apply the same
Yeah.
algorithms that you were using on your real robot.
Yep.
And you mentioned about being a little bit shaky. Well, it it's it depends, okay, how much shaky. But if it doesn't collide against your, so you get like an inclination of the laser
Yeah.
colliding against then it can work. You don't have to worry about this shaky thing, more or less, because the algorithm for navigation is going to work. We use this method into humanoid robots,
Okay.
and myself, I put it into the shoes, let's say the shoes, or the feet of the robot, of the
Oh, okay.
humanoid. And then he was walking like this, and he was doing all
Oh,
the
right, with a
steps.
laser on his feet.
Yes, exactly. And I was using the navigation system, the same navigation system. At
Okay.
that time, there was no ROS, but it, so the same principle within
Mm.
ROS. So there was no problem really, and it could do the whole thing of navigation, the mapping, the localization, and then using that for doing the path planning and moving along the path.
Okay. We'll see how it goes. At the moment, it is
So
very, it does pitch and roll quite a bit if I take steps that are too
uh-huh.
big. Have a look at OpenDog version 2 part 6 where it does do walking. But yeah, that's very rudimentary gait though, so there's more coming, which I'm working on at the moment to try and slow the steps down so it can take bigger steps without its feet getting caught on the ground and stuff. But yeah, I think
Oh,
it'll probably be all right. It'll just take a bit of tuning.
okay. Yes, so we are going to be attentive to your channel. By the way, so before finishing, so can you tell the audience where can they find you and how they can support your work?
Yeah, sure. So I'm on YouTube. It's James Bruton is my YouTube channel name. On Instagram, Twitter, and everywhere else as XRobots UK. And I'm on Patreon, patreon.com/xrobots.
Okay, perfect. The Patreon, remember, the Patreon is for supporting the job of the work of James. So you kind of subscribe to his job. It's like that, right? The Patreon
Yeah,
works
it's basically to make money from people who want to support me. So it's like
exactly.
ongoing crowdfunding is the best way to look at it. Yeah.
Okay. Ongoing crowdfunding. So yeah, so please support James for that, because he can keep doing projects as cool as the ones that he has presented. And yeah, I will put a link on the show notes also, in case that you don't know how to find it. Then go to the show notes, and then will be all those links that he mentioned, among all the other things that we have mentioned along the podcast. Okay, so that is all for today. James, thank you very much. My honor to meet you, even if it's not in person, but face to face on the screen. Thank you very much for being
Okay,
here.
thank you. Thank you for having me on.
And then so let's go. This is the end of the podcast. So, but before finishing, let me tell you that we are trying to achieve a 10x increase in the number of subscribers that we have on the podcast. So, for that, we need your help. How can you help us? Then by going to iTunes or a Stitcher and going there and then giving us 5 stars, putting a comment there about what you think about the podcast, and of course, recommending our podcast to your friends, your colleagues, and all that. So that is all for today. Thank you very much, and see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.